Good day everyone! For today's lesson, we're discussing about computing for the parameter in statistic. What is parameter? Parameter is the measurement or quantity that describes the population, while statistic is the measurement or quantity that describes the sample. When we say sample, it is the subset of the population. For example, we have this situation. The results of the scores in biochemistry of graduating students in the board exam has come out. Compute the population mean, population variance, and population standard deviation. So this is the scores obtained by 10 students: 89, 91, 93, 87, 86, 92, 88, 94, 85, and 95. First, let's compute the population. Compute the population mean, so here's the formula. Mu is equal to summation of x over n, add the given value and divide by how many given value, where mu is the population mean and the summation of x, sum of the measures, and n stands for number of elements in the population. We will take the population mean using this formula. All we have to do is just add them all up and divide by 10 because n4 represents number of elements in the population. If we add all of these, that is 900. Then 900 divided by 10 is equal to 90. Next one, to compute the population variance and standard deviation. So here's the population variance formula. Sigma squared is equal to summation of x minus population mean squared over n, where x is given data, mu is the population mean, and n is the number of elements in the population. 89, 91, 93, 87, 86, 92, 88, 94, 85, and 95, as we have given earlier this 10. Let's compute the population variance using this formula. We need the value of population variance that we obtained earlier, which is 90. So let's add up each score and subtract the population mean squared we get, like this. So let's simplify. Why 10? Because our elements are 10. And here's the answer. So this is our population variance. Taking the population standard deviation is also just a symbol. In the population variance, there is squared and the population standard deviation is none. You just take the square root of the population variance, and that is square root of 120, and the answer is 10.95. Our population mean is mu equals 90, population variance is equal to 120, and population standard deviation is equal to 10.95. They are what we call parameters. While in statistic is compute the sample mean, sample variance, and sample standard deviation. We will select 5. Example: 89, 92, 88, 95, and 86. Here are the ways to get the sample mean, sample variance, and sample standard deviation. To compute the sample mean, just the same process, but the difference is its symbol. Where x bar is the sample mean, the summation of x, sum of the measures, and n number of elements in the sample. So here's the 5 we selected from the 10 scores. To compute the sample mean, here's the formula. X bar is equal to summation of x over n. And 89 plus 92 plus 88 plus 95 plus 86 over 5 is equal to 450 over 5 is equal to 90. To compute the sample variance and standard deviation, here's the formula. S squared is equal to summation of x minus x bar squared over n minus 1, where x is given data, x bar is the sample mean, and n is number of elements in the sample. These are the 5 we got in the random selection, and our sample mean is 90. Compute the sample variance and substitute in the formula so as we did with population variance. Let's sum it up and subtract 90 from the sample mean, and then squared, so 89 minus 90 squared plus 92 minus 90 squared. If we simplify, this is the answer. 50 over 4 is equal to 25. You just take the square root of the sample variance, and that is square root of 25. The answer is 5. The sample mean is 90, sample variance is 25, and sample standard deviation are what we called statistics.